This video will demonstrate how to apply the California TDV factors to an EnergyPlus model. CBECCOM is the California Building Energy Code Compliance software for non-residential buildings. So you can install the software from their website. The current approved version is CBECCOM 2019 1.2. And once you install it in your Documents folder, there's a number of sample projects in the CBECCOM 2019 projects folder. If you go to Standard Model Tests, we'll be using the Office Small prototype. So I'll just copy this Office Small prototype to somewhere outside this folder. So if we just open that up and simulate it, the results are shown in terms of energy and TDV per square foot. These prototype models are what's known as zero compliance models. So they meet compliance with a zero compliance TDV margin. In this case, it's a little off 0.03. So what we'll be trying to do is to match these standard design TDV values using EnergyPlus directly and applying the California TDV factors to the EnergyPlus file. You can find the EnergyPlus files that are generated by CBECCOM in this run folder. This -ab.idf is the baseline or standard design, and the -ap is the proposed design. We'll just use the baseline standard design as our example model. The most straightforward and manual way to do it is if we just copy this IDF file and run it in a separate folder. And we just run that through EnergyPlus version 9. We can select the weather file right from the CBECCOM 2019 data folder in EPW Sacramento Executive Airport and just simulate that. If we click on meters, it already has these meters set up for all of the end uses in electricity and gas. So if we just copy in the TDV factors for that climate zone, if we go to Documents, CBECCOM 2019 Data, Documents, Rule Set Source, T24N, Rules, Tables, there's a file called 2019 TDV by CZ and Fuel. So we'll just copy that and paste it in our model folder. And open that up. These are all the TDV factors for electricity, natural gas, and propane for each climate zone in California. So if we scroll over to climate zone 12, we have TDV 12 electricity and natural gas, and we can see these are in kilo-TDV per kilowatt hour and kilo-TDV per therm. So if we copy these two rows and paste them in our meter output file, we can use these to calculate our TDV per square foot and check it against this energy use summary tab in CBECCOM. So we can just spot check a couple end uses like interior lights. The first thing you'll have to do is convert this because right now it's in joules, and these TDV factors for electricity are in kilo-TDV per kilowatt hour. So if we just use the convert function in Excel, we can convert that from joules to kWh, drag that formula all the way down, and then if we do the sum product of this column and our electric TDV column, we get 157,000, but then we have to divide by the square footage because remember these are in TDV per square foot. And we can see this model is 5,502 square feet of conditioned space. So we'll divide that by 5502. We get 28.68. That should be the TDV per square foot for interior lights. We can see from our Energy Use Summary tab, 28.68 TDV per square foot indoor lighting. So we can see that's accurate. Let's just check one of the gas end uses. Heating gas in joules, and convert this heating energy from joules to BTUs because the convert function doesn't have therms. And then we could just divide that by 100,000 to get therms. Drag that formula down, and now if we do sum product of this column and our gas TDV column, we get 55,510 divided by 5502, our square footage, and we get 10.089 TDV heating gas energy. And we can see that matches the CBETCOM results. So I'm not going to go through every end use here, but we can see how we can do that the manual way. You can set up a spreadsheet where it automates some of this. But now I'll demonstrate how we can have EnergyPlus do all this multiplication for us. So there's actually an example file in the EnergyPlus folder. So if we go to EnergyPlus version 9, in the example files folder, there's an example file called 5-zone TDV. And if we open this up, we can see in the file description, this file provides an example of using the source energy schedule in the fuel factor object and using the schedule file object and the TDV, time-dependent valuation. So if we search for fuel factor, we can see at the bottom of this IDF file, we've got fuel factors for gas and electricity. So we'll copy these and actually paste that in our Office Small model. And we'll put it at the bottom. Paste the fuel factors. And notice that these fuel factors reference a source energy schedule name. Elect TDV from CZ06COM and Nat Gas TDV from CZ06COM. If we scroll up a little bit above this, we can see those schedule file objects, so we'll just copy those too and paste them in here. And now we'll just replace this file name with our new 2019 TDV factors, which we already pasted in that folder. 2019 TDV by CZ and fuel.csv. And if we open up that CSV file, we can see we want to skip 14 rows before we get to our first TDV value. And for climate zone 12, the electricity TDV column is in 34, but actually these numbers start in the third column, so we'll add 2 to that. So electricity, climate zone 12 is 36. Natural gas, climate zone 12 is 37. So we'll change that here. Column number for electricity is 36. Skip 14 rows. Natural gas, column number is 37. Skip 14 rows. And if we save that and run this model again, now if we open tables and search for source energy end use component summary, this table is the TDV for each of the end uses. We'll just spot check the heating energy again, divide that by our building square footage of 5502, 10.09, and that matches CBETCOM. So now if we want to extract those TDV results, we can use the make results batch file that comes with model kit, paste it in that folder, and with a results text file that's pulling from that source energy end use component summary to extract all the TDV results. So now we have all the electric TDV and all the gas TDV, so we can divide these all by 5502 to get our TDV per square feet. So these were the more manual ways of getting TDV results out of an EnergyPlus model. And the next video I'll show how to use ModelKit to automate this TDV results process and be able to do it dynamically for multiple climate zones.